In this video, we will see the electromagnetic wave equation in free space. So the condition for free space is sigma equal to 0, mu equal to mu naught, epsilon equal to epsilon naught. Right? Now to derive the wave equation, we should take the Maxwell curl equations. So one of the Maxwell curl equation is del cross E equal to minus mu dou H by dou D. Actually it is minus dou B by dou D. No? So B means magnetic flux density, that I am writing B equal to mu H. So we will get minus mu dou H by dou D. Now expanding this curl by using the curl expression, in the first row is unit vectors, second row is the differential terms, third row will be the electric field vector components Ex, Ey, Ez. And right side also I can write minus mu dou by dou D of H is the vector, right? So we can write in terms of X, Y, Z. And now we are assuming the wave is along Z direction and electric field is in X direction, magnetic field is in Y direction. So that means Ex component will be there, Hy component will be there. Remaining all components will be 0. So in that case, here Ey equal to 0, Ez equal to 0. Only Ex component will be there. And there is a variation along the Z direction. So that means this dou by dou X and dou by dou Y will be also 0. There is no variation along the X and Y direction. Wave is propagating along the Z direction. That's why these two also 0. So if I substitute these 0 and expanding, we will get dou Ex by dou Z. That means this component. This, if you substitute dou Ex by dou Z minus 0, that equal to minus mu. Here also Hz component 0, right? And Hy component will be there. So we will get dou Ex by dou Z is equal to minus mu dou Hy by dou D. From where we are getting this? After expanding this left side term and right side term. Right? Left side Ay component is there, right side also Ay component will be there. So equating, you will get dou Ex by dou Z equal to minus mu dou Hy by dou D. Let equation number 1. Similarly, second Maxwell curl equation is del cross H equal to, actually it is del cross H equal to, what is the Ampere's law? J plus dou D by dou T. Okay, but where J is the conduction current density, J equal to sigma E, right? Now in the free space, sigma equal to 0, then J will be 0. That's why I am not writing here J. So only we are writing dou D by dou T. D means electric flux density. In terms of electric field intensity, we can write epsilon into E. So epsilon is a constant, separately I am writing. So epsilon dou E by dou D, right? Now expand this curl and this electric field expansion. So curl equation, first row is the unit vector, second row is the differential term, third row is the magnetic field vector. And here electric field is a vector, then I am writing in X, Y, Z components. Right? Now by using the earlier condition, what we assume, magnetic field is in Y direction, electric field is in X direction, wave is along the Z direction. So in that case, Hx will be 0, Hz also 0. Only Hy component will be there. Here also Ey, Ez will be 0. Ey, Ez will be 0. Only component is left out is Ex, Ax. Right? So after expanding also, the only Ax component will be there, which is dou Hy by dou Z. And here also X component. Both equating we will get dou Hy by dou Z equal to minus epsilon dou Ex by dou D. Let equation number 2. Now, and partial differentiation. You do partial differentiation equation 1 with respect to t. Right? Doing the partial differentiation of equation 1 with respect to t. What is equation 1? Dou Ex by dou Z, right? So, for the this equation, we are doing the partial differentiation. So, then dou by dou t of dou Ex by dou Z is equal to minus mu dou square Hy by dou t square. In the right side, both are with respect to t. That's why you will getting the dou square. See here, partial differentiation. That's why these two variable acts as an independent variable. So I can interchange these two. Right? We can interchange these two. Then we will get dou by dou Z of dou Ex by dou t is equal to minus mu dou square Hy by dou t square. So from equation 2, this dou Ex by dou t I can write as, right? From equation 2, you can write as minus 1 by epsilon dou Hy by dou Z. So which is equal to minus mu dou square Hy by dou t square. So minus will be cancelled out. take this epsilon right side. So overall you get dou square hy by dou z square equal to mu epsilon dou square hy by dou t square. So whereas velocity of light formula c equal to 1 by under root mu epsilon, right? So from this I can write mu epsilon is equal to 1 by c square. So that's why in place of mu epsilon I have written 1 by c square dou square hy by dou z square equal to 1 by c square dou square hy by dou t square. Similarly, this is in the form of magnetic field. Similarly, if I do earlier I have done partial differentiation of equation 1. If I start with the equation 2 partial differentiation, then simplify following the same steps, you will get the in terms of electric field wave equation. So dou square ex by dou z square equal to 1 by c square by 1 by c square into dou square ex by dou t square. So these two are called the equation of the EM wave in free space. In generalization, we can write simply dou square e by dou z square is equal to 1 by c square dou square e by dou t square. So simply we can write like this. This is the equation of the free space, EM wave in free space. So based on this, previously in the gate they asked the question. The first question is, if a plane electromagnetic wave satisfies the equation dou square ex by dou z square equal to 1 by c square dou square ex by dou t square, the wave propagates in the what direction they are asking. So directly it is given the EM wave equation in free space and asking that wave is propagating in what direction. See here z is there means it is z direction. Simply you can write here z is there, so the wave is propagating along the z direction. So by deriving this, see we assume the wave is propagating along the z direction, that's why you go to the dou square by dou z square. If I take x or y direction, then if it is x, dou square by dou x square will get. So from this expression we can say the wave is propagating in what direction. So after by our assumption wave is propagating in the z direction. That's why by seeing the this question we can say directly wave is propagating in the z direction. One more question they ask: the electric field component of uniform plane EM wave propagating in the y direction in a lossless medium will satisfy the equation. Now the same question, just change the wave propagation direction is y direction. So in that case, so you see, that's why option third, if you observe, dou square ex by dou y square equal to mu epsilon dou square ey by and dou square ex by dou t square. See, wave is propagating in the y direction, that's why y term will be in the denominator. So remaining all will be wrong. Okay, thank you.